In this video, you will learn everything about carbon dioxide and its effect on mushroom cultivation. The effect of CO2 and temperature on the rate of mycelium growth and mushroom size is very important. Even though in air the natural concentration of oxygen is around 22%, whereas CO2 is only 0.01%. Plus, still the CO2 plays one of the primary important role in the development of the fruiting bodies. We can say that CO2 is a necessary evil. It actually depends upon which mushroom strain we are cultivating. For example, see, this is an oyster mushroom. The healthy pinheads are growing naturally, everything seems fine, and when the mushrooms are given a favorable condition, they grow into this kind of mushroom which are fruiting body. Here you can see in this farm there are kind of ventilation space from where the air circulation is going through. But what if the room is enclosed and there is no air flow inside, there is no oxygen? Then the CO2 amount will drastically increase, and these are the symptoms of it. You can see the mushrooms will start growing like kind of long elongated stems, deformed shaped. These deformities are the result of excess CO2. It's also true for several varieties of mushroom like button mushrooms, shiitake mushrooms. In nature, mushrooms are like the humans. Unlike plant, they do need oxygen. When they are deprived of fresh air and light, they start searching for the same. In that process, they start forming elongated stems. And without the ideal condition, how will they develop their complete fruiting body? The mushroom fruiting body, the function of it is that the gills produce and eject strains of spores, and it's done for further multiplication. They are like seeds for the mycelium to grow, but these deformed shapes are unhealthy, and for few strains they won't even grow properly and they will not open their caps. Hence the CO2 is very important, even though, because for mycelium growth, if the CO2 is not there, it won't grow in the vegetative phase. But another important thing is the temperature. Without the optimal temperature, they won't even fruit and they will develop contaminations like these green molds, black molds, deformed mushroom heads. And due to high CO2, then the pinheads and fruiting body will be deformed. So these both things are the examples. See, these are the example of button mushrooms which have been deformed due to the concentration of excess CO2. Main fact is that we require a system where we can mix outside clean air which is full of natural oxygen and mix it up with the inside air which is inside the farm. We can install this kind of exhaust system which intakes fresh air from outside, pure air, and it rotates through air vents which are installed inside our farm. And in that way our farm will be in our control and we will be able to influx air whenever we want. So these kinds of vents should be installed in the mushroom farm, which give us complete control upon when to open the exhaust and when not, because there are a lot of mushrooms which are tolerant to CO2 as well. Because shiitake mushrooms is an example, they are quite hardy, they won't elongate much. There are certain varieties of mushroom, in fact they require high CO2 concentration, hence we also provide them willfully. The example of them are the king oyster mushrooms. The king oyster mushroom, milky mushrooms, enoki mushrooms all require high CO2 concentration during the your phase, the fruiting phase. The stipe and stem portion of these mushrooms are in more demand in the market than the caps. As these are delicious, the stems are very delicious. Unlike oyster mushroom, which is kind of chewy and very hard, and the gills of them are in more demand, but for the mushrooms like king and enoki, we need long elongated, hence for that we require higher CO2 concentration. Hence enoki is grown in closed dark places where in the absence of light they start developing long elongated stems. Mushrooms like king and milky develop big fat stems due to high CO2. These are the traits very desirable in them, as their stems are juicy and soft. They blend with a lot of dishes and their caps are not much in demand. These were all the fruiting stages where you can see the effects, how it developed in the fruiting stage. Now let's talk about the mycelium growth and the vegetative phase. The vegetative phase is different from the fruiting stage. The vegetative stage requires a lot of CO2. The fruiting bags made of polypropylene or the beds are often full of CO2 because mushrooms are continuously growing. Hence, maintaining high CO2 is quite easy at that stage. The fruiting blocks are full of active mycelium. They are continuously producing enzymes which is covering their substrate, and they are breaking it down, the nutrients inside from it, and absorbing sugar. Due to further respiration, a lot of heat and CO2 is generated. Hence, during the vegetative phase, the maintenance of CO2 is quite easy. Hence, we make also holes and we keep it a breathable air passage inside the fruiting bags. Otherwise, sometimes due to the excess CO2, what may happen that myceliums even won't grow. Hence, that's the complete picture. We need CO2 more during the vegetative phase, and it's true for every variety of mushroom, but during the fruiting stage it depends upon which variety you're growing. I hope you liked our content and subscribe. Have a nice day. Happy mushrooming.